Hello, everyone, and thank you for joining us for today's webinar on From Analytics to Action, the Life-Saving Impact of Video Intelligence. I'm Joel Griffin, Director of Thought Leadership and Brand Strategy at ISS, and I will be your moderator for today's program. Given the recent boom in video AI across security and safety, people are now rethinking what's possible with surveillance technology. Once seen as a primarily reactive post-event forensics tool, video networks are being increasingly leveraged to provide organizations with a proactive security posture. Whether it is being alerted to the presence of someone loitering in a parking lot, people fighting in a stadium, or a fallen person in a healthcare setting, people now expect the ability to do more with their existing video infrastructure. In today's program, we're going to explain what makes ISS and our suite of AI-powered analytics different in the market, and how our technology is being proactively used to mitigate risk across industries and applications. Today's webinar will be broken down into several parts. Following a quick introduction of today's speakers and a brief background on ISS, we'll delve into what makes SecureOS and our portfolio of 50+ analytic modules different. That will then be followed by an in-depth overview of Tracking Kit and FaceX with examples of how they've been used to address a wide range of threats. We'll then take a look at our SecureOS soffit pedestrian safety system that is being used by cities to meet their Vision Zero goals. And then we'll conclude with an overview of our SecureOS UVSS for under-vehicle inspection and how it's being used to protect high-security locations against hidden explosives, weapons, and other contraband. Finally, we'll conclude today's program with 10 minutes of Q&A with you, our audience. Please submit a question at any time using the Q&A button at the bottom of the screen. We will answer as many questions as possible during this time verbally. Your first speaker on today's program is Brian Friedman, Regional Sales Director for the Western U.S. at ISS. Over the course of his nearly two-decade career in the security industry, Brian has headed up sales efforts for some of the industry's most prominent surveillance manufacturers, including prior stints at Vicon, Avigilon, and iPro prior to joining ISS. Next up today will be Joe Harvey, ITS Market Sector Leader for ISS. Prior to joining ISS, Joe worked in various leadership positions at traffic and parking safety solutions provider TAPCO for more than a decade. During his time with the company, Joe led market development efforts for the company's wrong way alert system and also served as project manager for its DMS product line. Finally, today, you'll hear from Phil Jensen, Director of Sales for Under-Vehicle Surveillance Systems at ISS. Prior to joining ISS, Phil served as Director of Government Business Development at Atmospheric Plasma Solutions, where he helped drive market expansion efforts for the company. A 21-year veteran of the U.S. Coast Guard, Phil has also held leadership roles at multiple organizations throughout his career, including Advanced Detection Technology, SureID, and Secure West International, just to name a few. So without further ado, I'm going to turn the presentation over to Brian. Brian, take it away.
Thank you, Joel. I appreciate it, and welcome all to ISS. For those of you that don't know, ISS stands for Intelligent Security Systems. We have been around almost 30 years right now. We are a US-based company based out of New Jersey with 19 global offices, 400,000 deployed projects around the world globally, 7 million plus cameras under the command of our software called SecureOS. We have 600 plus employees, including 200 plus engineers. We are heavy on the development side, which means we are always trying to be on the cutting edge of technology. Few key partners or case studies, if you want to call them that, is Mexico City for city surveillance, Caltrans here in California, where I'm located, where we do LPR and tolling up in Northern California. The FIFA Cup, World Cup, we've done that several times. And then Bruce Power, which is a Canadian nuclear facility. Joel? Thank you. So what we do is different than a lot of our competitors out there. We do what's called neural network analytics. And for those of you that don't know, it's a type of machine learning where we analyze the data, find patterns in the video, and make predictions. The advantage of that is that it's incredibly accurate. I've seen other analytics out there, and we are over 98% accurate. With that being said, we offer 50 plus analytics out there, all which are proven and very, very accurate. Those include container number recognition and tracking. I'm doing a deployment next week for containers coming over the border where we take the numbers, the US dot numbers, and the container numbers and give the data associated with that. Face as a credential. Our facial recognition is so accurate, we can actually use that as an access control solution to open the doors as well. Facial recognition, again, facial detection or recognition, however you want to call that. Again, incredibly accurate. Fallen person detection. This has become huge because of liability for many facilities that get sued for millions and millions of dollars. And we can detect and send alerts when someone falls. Fight detection. Someone raises their hands and tries to hurt somebody. We get alerts on that. Intrusion detection. So someone comes into your facility that shouldn't be there. We can get alerts as well. ITS and tolling is something that Joe Harvey will be talking about shortly. We excel in that as well. License plate recognition. We were one of the founders in LPR close to 30 years ago. Again, very, very accurate. And we have plates from around the world, so that is global as well. Loitering detection, where we set parameters for how long someone could be in a specific area. Object left behind. Pedestrian safety, which Joe will touch on in a bit also. People occupancy detection, where we can detect how many people in a certain area. Situational awareness and tracking kit, we will talk about in a moment. Smoking and vape detection. A lot of our competitors actually have to have a special device to detect on vape. We do not. It's all done through video. Vehicle and train undercarriage anomaly contraband. That's something that Phil will be talking a bit for under vehicle detection. Next slide, please. So tracking kit, where this is such a powerful tool is that we are able to put up to 10 analytics on one camera. A lot of our competitors, or all of our competitors, generally it's one or two analytics per camera. So therefore, we can reduce the amount of cameras needed on a particular site. Those analytics can be crowd detection that we talked about, object left behind, loitering, running detection, person falling down or fighting, someone raising their arms or running dwell time. And again, we can do up to 10 analytics on one camera at a time. So it's very powerful, and it can be also associated with mapping as well on that particular camera. It's highly configurable and based on customer needs, meaning that you can have a shopping list of analytics that you will want to use at any particular time on any camera. So again, very easy to use. And what I do want to say, it's not on the slide, what's very important that you think about, a lot of our customers don't think about, is what do I do with those analytics? And what we offer is tons of data associated with those analytics as well, such as how many people have fallen, how many cars there are people in an area. Joel, next slide, please. 2 decades of global success for FaceX. Again, we were one of the founders of facial recognition over 20 years ago. Some of the key features of this unlimited database, meaning that we can extract faces from your video. You could download faces into facial recognition software as well. What I like to look at here, I've worked for other facial recognition companies in the past, anti-spoofing detection. This is huge because what a lot of companies don't realize, or people don't realize, what if you have an iPad, you hold it up in front of that camera, it opens that door. So we have anti-spoofing detection that you could turn on where you cannot spoof that camera. So it is incredibly accurate as well. Again, we use neural network-based algorithms for that, so it's incredibly accurate, over 98% accurate. A lot of customers get excited about facial recognition, realizing later, after a major investment, that it is not accurate. It's bringing up a stop sign instead of someone's face, or it's bringing up a woman instead of a man. Ours is incredibly accurate. And then you can create a watch list from there as well. So you can create a good guy list or a bad guy list. So you have high profile people coming into your location. You can get alerts when that person's coming on your property. And again, for example, if you have a person that should not be out of school, let's say, you can get alerted to when that person's coming on the campus. Next slide, Joel. Real world impact. So obviously we want to hear about how and where are we doing these things. This happens to be a particular incident at a stadium, a soccer stadium, where they had a known offender coming into the stadium there, a violent offender, entering the soccer match. And before that person was even in the stadium, in the crowd to enter, we were able to trigger an alert where the police were dispatched to come and pick that person up. So again, when you think of video, what do you use that video for? So if you have cameras pointing out your entrances or exits, wherever you want to put those, we can pick out faces out of a crowd. Very, very powerful. Next slide, Joel. Again, another real world impact case study here. This happens to be in Colombia, where they had a person that was attempted homicide and illegal possession of firearms in the past. It was in the database. As soon as this person entered into this public facility, we received an alert and the police were immediately dispatched. Again, this database is very, very powerful. Again, stadiums where there are tons of people coming in, it is a great tool. Next slide, Joel. So SecureOS at work. Again, we talk about FaceX and the models that we have and where it's deployed involving law enforcement and where we see this dispersed, right? So the particular one, a Florida hospital uses FaceX to identify individuals on the state's sex offender registry. So as long as we have access to a database, and in Florida we did, we had that list of sex offenders we were able to identify and dispatch the police or security in that case. Securing major public events. F1 track in Miami. Again, they used FaceX to successfully detain 3 persons of interest and apprehend an individual involving a physical altercation. And to that statement there, we've done other, for example, F1 in Las Vegas, we actually tested that FaceX on drones and deployed, and it is accurate and does work. Everyone hears about drones these days. Ensuring rapid response. During a proof of concept in New York, our fallen person detection analyzed and accurately identified people that were falling in a particular area. I believe there was ice or snow in a particular area outside a building, and they dispatched security to that event. Next slide, Joel. All right, and some of the other analytics we carry here on the left here, slip and fall. Again, we talk about this. This costs people and companies millions and millions of dollars, right? So you can see her on the left side here. This woman is lining up boxes in the warehouse. And in a moment here, you'll see what happens. She'll walk back here and whoops, and she falls. So it is very accurate. And in many cases, people claim they have fallen. And with the video, it's pretty cut and dry. They can't turn around and sue companies, right? Joel, on the right side here, if you can click that again. So gun detection, very powerful. Again, you'll see this guy is carrying a rifle. It could be a rifle, it could be a pistol, it could be pistol holstered. In this incident, I'm thinking my sister happens to work for the NFL in New York City. And most of us know what happened there. A shooter came in carrying a rifle into the building, went up there. Unfortunately, my sister wasn't there and started firing. But if we had our software in the lobby or outside, for those of you who have seen the videos, someone just walked up to the building carrying that rifle, people would have known about it. And this would have saved lives. Next slide, Joel. Again, some other great examples of our analytics. And again, I just want to emphasize how accurate these analytics are. The one on the left here is loitering. So again, this person seems to be casing the car, right? Walking around, checking it out. What's important here to know is that we set the dwell time. How long should that person be there before we dispatch security? Is it 30 seconds? Is it a minute? Is it 2 minutes? And loitering can pertain to really any type of situation where someone's just waiting around, going to do something bad, and we can send an alert of some kind. On the right side here, another fantastic example of firearm detection, right? So the person on the right there pulls out his gun, someone raises their arms, and we can send an alert as soon as someone takes out that weapon. Very powerful and very accurate analytics. Next. And we talked about drones at F1 last year. It's actually a year ago tomorrow, because the race in Vegas starts tomorrow. Drone capabilities grow for a situation where this could be either a tethered or non-tethered drone, where we could facial recognition or LPR in that drone. And that information will go back to our software, SecureOS as well, and give you the alerts needed, right? So again, cover a really broad area using those drones. I just want to mention before we move on, we are completely agnostic on the camera side, meaning If you or your customers have existing cameras, as long as they're IP cameras, we can use them as well. We are also agnostic on the VMS side, the video management system software. So if your customers have or you have software in place, that doesn't matter to us. We can reside on anybody's software. Next slide, Joel. All right, and this is, I believe, my last slide. So again, we talk about what do you do with that information that you're receiving from these analytics? What is that investment going to look like? And what is the true advantage? Because everyone's been talking about analytics for years. The advantage is extracting that information, being able to use that in case there is an event, right? Or use that for operational systems, right? If you want to know, for example, using a camera for how long, how many packages are being delivered by UPS or whatever it may be, we can extract that information and use that data to give back to you in reports. It's completely configurable by user. We can create custom dashboards for that information as well. So everyone likes to talk about analytics, but the question is, what do you do with the analytics? And we enable you to use that information to better your security or better your operation. Next slide, Joel. A couple of case studies here. This happens to be one of our largest for Mexico City. What they do is they have 6 command centers around Mexico. And if you look at that quantity of cameras, I believe it's grown since then, 65,000 plus cameras on our system. 1,000 of those are our LPR cameras, 1,000 are facial cameras, 2,500 are the tracking kit systems that I showed you, meaning where you can put 10 analytics on one camera, very powerful as well. We also have the ability to put in 13, in this situation, 13,000 speakers for mass notification. So this is a very large deployment. We do small systems also from 5 cameras to 50, but we also can go up to thousands and thousands of cameras. Next slide, Joel. And what I'd like to do is hand it over to Joe Harvey. He is our ITS specialist. Joe, it's all yours.
Appreciate that, Brian. So as mentioned previously, I am Joe Harvey. I handle our ITS division here at ISS, and specifically going to be covering our safety device, the Soffit. Joel, if you can skip to the first slide there. So all data that we can pull, and even things more recent as of 2022 and 2023, sees the pedestrian fatality issue continually rising since the early aughts of the 2000s. As roadway configurations and issues continue to be changed, the pedestrian and the vulnerable road users are the ones most at risk, and we are seeing the data show that they're the ones, unfortunately, at the wrong end of this data. There's even some charts from the Governors Association that show the pedestrian issue is actually remaining fairly flat during daytime conditions, but the nighttime conditions have even more of an upward trajectory than this data shows, really indicating a safety problem that we have out on our roadways. Joel, if you'll jump to the next slide. So ISS started to ask a question and do some research, and we found that over 75% of all pedestrians were killed in collisions during nighttime dusk hours, and close to 75% again are at non-intersection locations. If you think about pedestrian safety, a lot of mid-block applications are out there, and we'll take a look at the system here within those constraints, but the Soffit is unique because it does actually work quite well at signalized intersections, and because of the other side of our business in ITS, we actually have a lot of great data and ability to work within the signalized intersection framework. Joel, if you'll jump to the next slide. So what are the key issues that we're looking at? Lack of infrastructure and poor road design. If you think about some of the growing populations in areas, these roadways are not set to accommodate just the number of pedestrian traffic that we now see, both from just the walking, but also with scooters, bikes. We're really seeing designs that are potentially outdated or just not suited for our traveling motorist. Driver behavior and distraction. Being distracted by cell phones is not a new concept. This has been a conversation that's been going on for quite some time, but with the adoption of connected vehicles, you also have just a large amount of data inside the vehicles with alarms and noises visual acuity being taken away from the actual roadway and within the vehicle itself. And then obviously lighting conditions. We've already hit on that. But dark clothing, the pedestrian side of being distracted, and vehicles just not picking up where the pedestrians are at. Joel, next slide. One of the other things that we have taken a look at is the potential white noise of some of our more traditional safety measures within the marketplace. If you take a look here, historically, any of these safety devices have pulled drivers' attention to the outer edges of the roadway in order to indicate that a pedestrian is actually in the roadway, which is, in our belief, counterintuitive. If you're taking a look at things at the LED enhanced signs, the RRFB systems, even a Hawk system that's very high overhead, the traveling pedestrian within the crosswalk, everything is asking the driver to pull their attention away from the roadway, look to the side of the road to understand that they are in an active crossing, and then go ahead and take a look back at the crossing itself. That is where, and Joel, if you go to the next slide, our device, the soffit, actually starts to change the environment and really take a look at the key problem of identifying the pedestrian where they are in the crossing. So the technology, it is a dynamic illumination that actually travels with the pedestrian. As you see here from the little layout, we are using our algorithms and neural network in order to identify any vulnerable road user within the crossing and being able to increase that safety by cascading a light directly over top of them and traversing the roadway as they move within the crossing. Joel, if you go to the next slide, there's a diagram here that'll show you, and eventually I'll get to a video that you'll be able to absorb this much easier. But the soffit itself is an overhead light. During non-activation, the device is actually providing overhead lighting, much like your standard street lights. During activation, the light intensity is ramped up and directed on top of the pedestrian as they traverse the crossing. Once they exit the crossing, the lighting standard would go back to its original setting or even turn off. Much of it is a user preference or configuration, but this allows a driver to understand they're approaching a crossing, identifying exactly where the pedestrian is within the crossing, and then the system from a safety device be able to still live kind of in the traditional measures of what mid-block crossing and signalized intersections have had up to date. Joel, if you go to the, I believe, penultimate slide here. So the technology itself is made up of three pieces. It is the LED illuminator, an IP camera, and an analytics controller. We basically have a edge device or a nuke within the analytics controller that is housed all of the neural networking and really the brains behind the operation. The IP camera is a simple bullet camera within our suite of manufactured cameras. And then the LED illuminator is just a fixed mechanical unit that is not actually moving any of the LEDs. We are individually firing LEDs within that system to give the cascading effect that you'll see in the video in the next slide. A couple things on the specification to hit here and to kind of have an understanding of. One, right now the system is solely 120 volt or AC powered. If you just go back to my previous comment of this being an overhead light and being on throughout nighttime, you would need a solar farm and a bank of batteries that would just not be cost inducive in order to put the device out. Also is the height requirements. We want this up as close to 20 feet as possible. A lot of customers to date have done the 15 to 17 foot just based on standard ped pole heights within our industry here in the States. But the higher that you're going to get that light, the better light uniformity you're going to have within the crossing itself. And aesthetically, on approach, you have a better understanding, as you'll see from the video, of that light cascading over the pedestrian and being able to follow it in a much smoother transition than potentially a little choppier, just based on how that light can get across the crosswalk there. The individual light is generally a 4-lane application. We have had customers take it out a little bit further, but again, intensity there, since you only have the one light per system. And finally, from just a service and warranty standpoint, I don't know if it states on here, but it is rated for 100,000 hours. That's just where we are still to date from an LED standpoint, but back that up with our warranty as well for a maintenance standpoint. And Joel, if you'll jump over to the video here. A couple points that I want everyone to be able to take a look at and see. So it's going to start, and you're going to see pedestrians enter the crossing. You're going to see the light cascading on top of them. But really the power of the device is its ability to capture every individual pedestrian because we're tracking the individual and not just a button push. Traditionally, button pushes activate a system. In this case, we are actually tracking that pedestrian and where they are within the crossing. You're going to see people entering crossings at different points in different directions, platooning like you see there. There's even a portion of this video where someone turns back and heads back and the light picks them up and travels with them. If you take the scenario of you're on approach to this crossing and a light is activated on the outer edges, one of those traditional flashing devices, being able to take your eyesight off and then coming back and actually identifying where that pedestrian is, or the valuable seconds we're losing, and what we're trying to do from a safety device standpoint in order to slow vehicles down or to completely get them to stop again. The other side of the device from just a safety standpoint is what you get from the data. And to piggyback on what Brian stated earlier, this is very enriched data and an area where we continue to push the device in order to provide our end users, the engineers, the public work department with the information needed in order to better understand their entire traveling roadway. If you understand the true counts of the pedestrians, the type of pedestrians in the area, if they're mobility devices, heavy bike users, a certain time of day that you have large platooning, you can better understand even your signal phase and timing or other safety devices that you have deployed and better utilize them within the system. The data really helps you understand a true picture of what is going on at any given crosswalk and is just a add-on to what the safety measure is as a device and what we see in trying to curb that steady increase in pedestrian fatality and issue. So that is all I have on the soffit. I will hand it off to Phil to continue the presentation.
Thanks, Jeff. Again, I'm Phil Jensen. I'm going to jump into the under vehicle surveillance system by ISS. Most common would be the undercarriage is one place where threats tend to be missed. And that's often because they're using older traditional technology, namely handheld mirrors. There are some disadvantages to that. You're only going to get about 30% of the coverage of the undercarriage of the vehicle. You're definitely going to be limited in the visibility of the hidden and recessed areas. It can be affected by the weather. It definitely slows the inspection points. I probably have thousands of inspection points throughout my career that I've ran, and I know slowing down traffic is it's an aggravation. There's no record or audit trail that you can use when you're using a handheld mirror. So there's also some disadvantages of using a dog. We see dogs at a lot of checkpoints, especially on high security facilities. Dogs can vary. They get tired. Heat affects them and weather conditions. They also require a handler, additional training. You got to have a kennel. There's no visual evidence of the investigation, so there's no audit trail that you could utilize when you're using a dog. And they become less effective when you're utilizing them in high traffic situations. There's also pits. I've seen some military installations that have a commercial inspection point where they have a security officer or a military policeman down in a pit as the vehicle transits it over the pit. They inspect it from the bottom visually. Again, it's expensive to build that out. It's expensive to maintain. It can flood. It slows the inspection time for the officers. It creates congestion at the gate. They're dependent on human judgment. So a lot of times if somebody's tired, just like a dog, the fatigue can start to set in for the officer and you can start to miss stuff. So our goal with the UVSS is to give you clarity, speed, and intelligence at your access control point. So with that said, I'll start in with this slide here. This slide is going to capture the core promise of our platform. We set the standard in threat detection because we deliver clarity, consistency, and intelligence at the moment of access. What you see here is the heart of our undercarriage solution. It looks simple, but every part of it is engineered for performance under real conditions. So our system here, as you can see at the top of the slide there, is our under vehicle surveillance system. It has LEDs that are embedded in it. It's a variable lighting system, so it adjusts to the lighting that's available. You can see the center is where the camera dome is, and it has a deflector that keeps it from being damaged. The entirety of the system weighs 55 pounds. It's just over 38 inches long and just over 12 inches from front to back. So super portable, super easy to get out and around. We can use it in a semi-fixed or a fixed position. And we've also got a newly engineered, completely mobile, rapid deployable system. Next slide, please. So this slide is going to show you what a typical under vehicle surveillance system installation would look like. On the left-hand slide, you can see a competitor. The installation piece of this is extensive. You're going to spend days, if not weeks, with the access control point closed down due to construction of the installation. If you look to the right, our system is compact, 55 pounds. You see two gentlemen there installing 8 anchor bolts to the surface of the road, and that is the installation. So our installation, to include getting the system up and running, is hours, not days or weeks. So our systems are rated IP68 and IK10, which means it's built to survive bad weather, water, impact without being buried in the concrete like some of our competitors. You don't need to shut down lanes or tear up pavement. One of the good advantages of our system as well is that when it comes to maintenance, we have very little maintenance. But if there is a maintenance event that needs to happen, our system is surface mounted. We don't have any of our parts buried in the concrete, because if you have to repair or maintain some of our competitors, you have to start ripping up concrete again. So it's another small construction piece that you got to do just to repair the equipment itself. So our maintenance is simple. The unit sits on the surface. You're able to look at it. You're able to do anything that you need to do maintenance-wise. Next slide, please. So this slide goes to the heart of why different facilities around the world choose our system. The system uses advanced AI to analyze undercarriage video in real time and automatically highlights suspicious objects. So ISS has a unique capability that kind of drew me to ISS. We have what we call a first pass anomaly detection capability. Some of the other manufacturers out there require a historical reference image of the undercarriage of a vehicle before they can do a comparative analysis. Our system, through our neural network and analytics, is able to determine if there's a suspicious object on the first pass over our under vehicle surveillance system. So that's really unique to us, and it's a super cool capability that we're able to give customers out there. So what that's going to do is going to remove the burden from the operator to identify suspicious objects. Again, it goes back to fatigue, experience, how much traffic's going through. We're actually going to be able to alert that operator to something that's suspicious automatically, so it can be verbally or text or whatever. It can highlight on the screen, but that officer is going to be drawn to that suspicious item. Our library of anomalies is globally developed, and we update it on a quarterly cycle, so it is constantly evolving. So our capabilities are only getting better day by day. And Brian said something at the beginning. We have 200 plus engineers. I just had a call the other day. We're now up to over 400 engineers. So our company takes innovation seriously, and we're doing it on a daily basis. So it's incredible what we can do, and I'm glad that we're doing it. So our system is also able to send alerts to command centers. So if you did get something that was suspicious in the undercarriage and the operator saw it and it was alerted, you can also send that to a command center or whoever the commander is in charge on that scene, so that they're also alerted at the same time as the operator. And then they can move it on to secondary or whatever the SOP is for that. The other thing that we're going to be able to do is when we image the undercarriage, we're collecting 100% of the undercarriage image. So wheel well to wheel well, front to back, and you're going to be able to see the entirety of the undercarriage. Some of the stuff now out there is big, would be like an X-ray portal for a vehicle. So what that does, it looks for different densities. So those densities are not always so telling as the visual high definition image that we're going to be able to provide that can be integrated into that portal where you're getting 100% visibility through the high and low density of the backscatter, and then also the visual of our system of the undercarriage. So if you're utilizing portals, we're a terrific add-on to create that layered effect of threat detection at your access control point. We have a centralized platform. All of our stuff works off the SecureOS platform that Brian and Joe spoke of earlier. We can integrate facial recognition. License plate recognition is integral to the UVSS operation. We do not require ground sensors or ground loops or presence sensors to detect a vehicle. We use our analytics from the LPR capture to initiate scanning or imaging of the undercarriage. So what that does for you as well as end user who's saving money is you're not having to complete as much civil work for the installation because we're not doing additional ground loops or presence sensors. And next slide, please. So this would be your typical architecture. So you have the ramp itself. That is an older generation ramp. You can see on the bottom of it is the 2.5 ramp. It has a protective camera housing on the bottom. The new 2.9 system is flat. So it is a completely surface mounted with 8 anchor bolts. From that ramp, you'll have power and cable, and it runs off 120. So same thing, you're going to be able to run it off whatever plug is available there. So you'll have power and data running from the ramp to the controller to the right-hand side there. Then the LPR will have Cat6 cable running to the controller. And then you have a monitor, and down on the right-hand side, you see the GUI. So you have the operational picture, so the scene camera that's capturing the license plate. You can see the undercarriage of the vehicle itself. And then to the right, you see the LPR capture with the plate pictured, as well as an audit trail where you can go back and review individually each pass of that vehicle. That includes the undercarriage capture. And that comes in handy when you're doing audits or investigations, or God forbid you have an incident where you have to go back and review it. Next slide, please. And this slide here is an actual operational video. So you'll see the camera start to image once the vehicle approaches the ramp itself. And if you look in the top image there, it's doing a historical comparison. You can also see some of the other tools being used: magnification, magnetic presence sensors, and then you'll see the red bounding boxes. That is our AI anomaly detection picking up on contraband. So the light yellow and green is also our magnetic presence sensors, and both of those are scalable. So the change detection or the comparison with the historical reference image and the magnetic presence sensors are scalable. So if you're getting it looks like almost like a false alert, you're able to scale that depending on your situation, what kind of vehicles you have, how low they are, how high they are. So you have a lot of tools here to use. The same thing on the right-hand side. One cool thing about our LPR capture, and I believe Brian mentioned it, we've been doing it almost 30 years. I think we're the best in the world at it. We're able to capture make, model, color, and you can see all that being audited or trailed and cataloged on the right-hand side of the screen there. So super functional, easy to use, The operator has a ton of data, and the next slide, I'll kind of go into that a little bit more. Next slide, please. So this is what I really want to brag on this. So this is the Secure OS platform. And what we've done here is we've integrated facial recognition. You can see that in the center there. We also have our LPR capture. We have a couple of scene cameras up to the left there. And then you have the undercarriage images on the bottom where they're doing a historical comparison. If you look all the way at the very bottom, you can see where the magnetic presence sensor picked up a kinetic device. So we have a layered approach where you're using a face as a credential. You have an LPR, you have color, make, and model. You have the under vehicle imaging that's doing historical reference comparison, as well as that first pass capability. So this is all on one operating system. So it's just how much of a threat detection deterrent do you want at your access control point? Because we're able to provide it across one ecosystem where you guys can work with it and build out kind of what you look for in your modules for detections. Next slide, please. So this was what I was talking about. So the one on the left-hand side is the ramp on the left-hand side is the 2.5. As you can see, it has protective camera housing at the bottom of it. The new system, the 2.9, is the flat surface mounted. Again, has 8 anchor bolts. That is all it requires for a surface mount. If you look to the right, we have the newly developed mobile system. So for rapid deployment, whether it be a special event, you want to extend your perimeter. If you want to do an informal access control point, you have VIPs coming to your facility. We can utilize a mobile system that operates with the same functionality and capability as our semi-fixed systems. So the Pelican case would contain the controller or the server. You can see a keyboard and a mouse, and then you have the monitor there in the lid of the Pelican case. The ramp itself would also come in a Pelican case. So you could use this system out away from infrastructure and use an inverter from a patrol vehicle and set up an impromptu checkpoint if that was a requirement. This is going to be ideal for those special events, concerts, court cases that have high profile visibility, parking garages during those high profile events. This would be the perfect setup because you can have it up and running in about 10 minutes, and then you can utilize it as long as you want to use it. And then you just pack it right back up, throw it in the back of the patrol vehicle or the security vehicle, and you're well on your way. And next slide. And I think that's it.
All right. Well, thank you, Phil. We have reached the time in today's program for Q&A. Again, you can submit a question using the Q&A button at the bottom of your screen. And we've had a few that have come in throughout the course of the presentation. This first question I'm going to direct to Brian, and that is, Brian, you touched a little bit on spoofing as it pertains to facial recognition, more broadly. But when it comes to, FaceX and our anti-spoofing technology, how does that adapt to some of the evolving threats out there, and what role does neural network technology play in helping us maintain an edge there?
Perfect. Really good question, Joel. So because we've been around close to 30 years right now, we have so much video stored. We're able to use our neural network learning to extract existing video to teach our analytics, right? So we probably have thousands of video clips of facial detection or FaceX where we can extract that information to make it the most accurate, right? And then we talk about anti-spoofing. I've worked for other companies before, and people print out pictures or have their iPad or have their iPhone, and what it looks for is that three-dimensional image when we put on our anti-spoofing to make sure that it is actually that person, if that makes sense. So it is a turn on, turn off type module where if you want it or not, but my feeling is these days, why would you not just turn that on? Anti-spoofing is huge. You don't want to be able to fool the system, right? And I urge you, whoever asked that question, compare our FASEC to other solutions out there. A lot of our competitors have solutions that are 70 or 80% accurate. Ours is easily over 98% accurate. Thank you, Joel.
All right, thank you, Brian. Joe, I'm going to direct this question to you as it pertains to the soffit. How does the soffit perform in, let's say challenging weather or low visibility conditions? What safeguards are in place there to ensure that it remains operational even when it's hard to detect people at a crosswalk?
So I think Brian kind of just hit on this, but and Phil potentially throughout his presentation there, but our ability at ISS and our R&D team to continually pull video and build the algorithm in order to identify these challenging environmental issues. So the device A being a nighttime solution and being able to get the camera to locally adjust during the dim portion, full nighttime, the ambient light, plus whatever light it's getting from our device. All of these had to be taken into account and looked at before we even released the product. And then through its years of deployment now, being able to more or less on the fly have our neural network identify the challenges and change or manipulate the algorithm to understand and enhance the visibility of pedestrians during fog, during rain. It is still video, so you're going to have some challenges when, you have a whiteout or a blizzard, there's going to be potential issues, but we continue to take a look at that, adapt to it, and try to work with camera manufacturers as well to just what is best in class in order to lower any potential issue we would have from one of those environmental concerns.
Thank you, Joe. Phil, I'm going to direct this question to you with regards to the UVSS, and this is something that comes up quite a bit as it pertains to throughput. But how specifically does the UVSS reduce false positives and ensure operational efficiency in high traffic environments in something like a border checkpoint or a critical infrastructure site?
So I think it goes back to how we layer our detection capabilities. So we're going to have an LPR capture. We can integrate the facial capture. We're going to have a historical reference image in most cases. If not, we'll have first pass anomaly detection. We have magnetic sensor detection where we can detect devices have been attached parasitically to the undercarriage. And then you also have the officer's experience and training. So going with that layered approach, that is the goal, is to minimize those false alerts and to slow down traffic. So if we can utilize all that through the training, the experience, and all the capabilities, I think you're going to definitely minimize any kind of alerts that you would have that you're getting with some traditional technology out there.
Thank you, Phil. Brian, I'm going to circle back to you as it pertains to the tracking kit. And you touched on being able to kind of, adjust your own dwell time and things like that within the SecureOS platform. So how do you balance, kind of those proactive safety measures and, looking for loitering and things like that, balancing that with privacy and, and setting the proper dwell time and things along those lines?
Well, I think initially you have to set up a proof of concept, right? Where you set up your cameras, you determine what your needs are. For example, how long does it take for someone to break in a car? How long is someone standing outside that vehicle before they actually break in? Kind of goes back to what Phil is talking about and training, right? Where you have to train the user or train the person using the software on what the needs are in specific cases. So my feeling is it's a lot of testing initially to determine where you need those analytics set, whether it's the dwell time, whether it's determining what faces you want to put in your system. Initially, what we do at ISS, we work with our end users and our integrators and our consultants to make sure that we help them to determine what is needed for their analytics. So we are actually on site to help with all that information as well.
All right, thank you, Brian. Circle back to you here, Joe, on this one. The When it comes to the soffit, how does it integrate with other traffic management systems and other other secure OS modules, and what kind of measurable impacts can someone see from those types of integrations?
Absolutely. From the mid-block crossing standpoint, the traditional safety measures are actually quite simple to integrate within. We get asked that quite a bit just based on the manuals that are out there, the traditional measures being written into specifications. It's really just a contact closure or our ability to communicate to that device's controller, which has been done extensively and is the easier lift between the two. It provides an additional sense of safety to both the traveling public, but also our end users, just because those devices have been out there so long. But it also provides us to work with and have new technology, have a little bit of a safety measure when you're talking about the mid block. At signalized intersections, it's a little more in depth, our ability to actually speak to the controller itself and make sure the interoperability isn't going to cause any concern or issue to that controller or any of its calls. But because we have a signalized intersection detection system as well, we have the knowledge base and the experience in order to ensure that you would have a seamless integration either into that controller or as a standalone unit. So a little more in depth, a little more of us actually hand holding there, but it is something that can be done and has been done from our side of things.
Thank you, Joe. Last question. And this one's for you, Phil. It's another on kind of our integration capabilities, but with its ability to integrate with other security systems, how does the UVSS contribute to a layered security strategy, and what are the challenges in implementing this across multiple sites?
So I think Brian touched on it. So our hardware is agnostic, so we're able to integrate into several operating systems. We do have the capability to network UVSS systems. So if you're on a large facility, it had 5 entry points, we're able to network that. And as long as there's connectivity, we're going to be able to run that stream to a control center. So if you have 5 locations, you can have 5 locations that are being viewed in a control center. So the integration, we have open APIs, so that is not usually a hurdle for us, and we're pretty simple to work with as well.
All right. Thank you, Phil. Well, that pretty much wraps us up for today's program. To close, I want to thank everyone who attended today's program, as well as Brian, Joe, and Phil for sharing their insights. To learn more, you can visit our website, issivs.com, or you can contact us directly at info@issivs.com. Thanks again.